Tidal waves are the largest oceanic waves on our planet. Tidal waves are formed by the gravitational forces of the Earth, the Sun, and the Moon. The gravitational forces of the Sun and the Moon pull on the oceans, causing the oceans to swell on either side of the Earth. As the Earth rotates, the tides go in and out, so that the Earth moves but the bulge of water remains in line with the Moon, giving the appearance that the tides are moving when it is, in fact, the Earth that is moving.
Greetings, everyone. We are the Group 4, and in this video presentation, the topic that we are going to discuss is all about tides. But before anything else, allow me to introduce my group mates. Here are the members of our group: Kenneth Miranda, Gapoy, Domingo, Lazo, and Dakanay.
So, good day everyone, my name is RJ Miranda, and today I'll be explaining about what are the tides. So, let me share this. Okay, so first thing is, what are tides? So, tides are the daily rise and fall of Earth's waters on its coastline. And as the tides comes in, the level of the water on the beach rises. As the tide goes out, the level of water on the beach goes down. So there is an instances where sometimes we can find that the beach can be, rises and rises down. So the next one is, so we have what we call here the high tides. So high tides are when the water reaches its highest point. So if you can see in the picture, so in the left side of the screen is we can see that the water is on high tide. So yeah, and the next one is what we call the low tides. So low tides are when the water reaches its lowest point. So as you can see in the right side of the screen is the boat is at the bottom. Okay. So when the highest parts or crest of the wave reaches a particular location, high tide occurs. So low tide corresponds to the lowest part of the wave, or its truth. The difference in height between the high tide and the low tide is called what we call the tidal. So the next thing is we're going to talk about the flood current and the ebb current. So it is a horizontal movement of water, often accompanies the rising and falling of the tide. So this is what we call tidal. So for the flood current, so it is the incoming tide along the coast, basin, and shores. And when we say the outgoing tide, that's what we call the ebb current. So the strongest flood and ebb currents usually occur before or near the time of the high and low tides. So the weakest currents occur between the flood and ebb slack water or slack current in the open ocean tidal currents. So it is weak. So near estuary entrances, narrow straits, and in low speed of tidal currents can reach up to several kilometers. Okay. So as we can see here on the picture, on the GIF, so that's it. So the flood current flows into the high tide, and the ebb current, so it's outgoing. So that's all, and the other will be continued by my next presenters. Thank you.
What causes tides? The gravitational pull from the moon and the rotation of the earth on its axis cause the ocean and seawater to bulge, producing the tides. Since the moon is close to the earth, it has a strong gravitational pull on it. Closer objects have a stronger gravitational pull. Since the moon is close to the earth, it has a strong gravitational pull on it Closer objects have stronger on gravitational pull. The moon pulls on the water on the side nearest to it more strongly than it pulls on the center of the earth. This pull creates a bulge of water on the side of the earth facing the moon. The water on the side of earth facing away from the moon has a less strong pull. As earth rotates, the different places on the planet's surface pass through the areas of the tidal bulges and have the change in water levels. The earth rotates on full turn in 24 hours, but the bulge of this water stays on the side of the moon. The bulge stays in its place as the earth moves under it. In places where there are tidal bulges, high tides is occurring along the coastlines. In places between the tidal bulges, low tide is occurring along the coastline. Sun gravity and tides. The sun is so large that its gravity also affects tides. At times, the sun and moon pull together on Earth's waters in the same direction. At other times, they pull in different directions. Think, pair, share. Why does the moon gravity affect tides more than the sun's gravity, even though the sun is much larger than the moon? The moon is much closer to the earth than the sun. Changes in the position of earth, the moon and sun affect the height of tides during a month. Spring tides occur 2 times a month. During a full and new moon, when the earth, sun, and moon are lined up, spring tides are higher and lower than normal tides.
Greetings, I am Karat Gapoy. So, as you can see here in the illustration, we can see spring tide. As we can see, the sun, moon, and earth are in CZG, meaning that the 3 celestial bodies are in straight lines. Because they are in straight line, their tidal forces act to reinforce each other. So, the ocean both rises higher and falls lower than the average. So, this is another illustration. So, as you can see, they are in straight line. So, spring tide occurs during the new moon and in full moon. The low tide typically occurs at the poles, while the high tides occur where the moon is located at. So if the position of the moon is between the sun and earth, then the bulge will be on the places where it is very near the moon. Let us now proceed to nip tides. So nip tides occur in between spring tides at the first and third quarters of the moon, when the sun and moon pull at right angles to each other. For the information of all, nip tides are not as high or low as normal tides. Since the sun and moon are at right angles, their tidal forces counteract each other, and the tidal range is smaller than average. By the way, tidal range pertains to the difference in water level between high and low tide. So, as you can see here in the illustration, there is a gravitational pull between the sun and earth, and there is also a gravitational pull between moon and earth. That's why these two forces counteract each other, so the tidal force is not that strong. So nip tide occurs during the first quarter moon, and then the moon is located at this position, and it occurs also during the third quarter moon, and the moon is situated in that place during nip tide. During nip tide, the low tides can be found on the perpendicular from the moon. So they are the low tides occur at the places of the earth where it is very far from the moon. In this case, on the sides. While the high tides occur on the places in the earth which are near the moon.
Tides occur at different times each day because the Earth rotates more quickly than the moon revolves around the Earth. So this is another view. Factors affecting tides. At a smaller scale, the magnitude of tides can be strongly influenced by the shape of the shoreline. When oceanic tidal bulge hit wide continental margins, the height of the tides can be magnified. The shape of bays and estuaries also can magnify the intensity of tides. Funnel-shaped bays, in particular, can dramatically alter tidal magnitude. The Bay of the Fundy in Nova Scotia is a classic example of this aspect, and has the highest tides in the world, over 15 meters. Narrow inlets and shallow water also tend to dissipate incoming tides. Inland bays such as Laguna Madre, Texas, and Pamlico Sound, North Carolina, have areas classified as non-tidal even though they have ocean inlets. In estuaries with strong tidal rivers such as the Delaware River and the Columbia River, powerful seasonal river flows in the spring can severely alter or mask the incoming tide. Local wind and weather patterns also can affect tides. Strong offshore winds can move water away from coastlines, exaggerating low tides exposures. Onshore winds may act to pile up water onto the shoreline, virtually eliminating low tide exposure. High pressure systems can depress sea levels, leading to clearly sunny days with exceptional low tides. So this is the tides at a monthly glance. And this is the table. Tide table becomes a major point of reference when a vessel tries to enter an inlet or a bay or an estuary for the purpose of docking. In water parts like this, the presence of a low tide will moor the vessel even before it can dock at the dockyard, and the high tide will disallow a vessel to dock at the required area. Since a tide table helps to predict the height of the tide, a captain will find it easier to maneuver the vessel accordingly and cruise smoothly into the intended destination. When it comes to shipping conglomerates and industry, a tide table is once again vastly beneficial because with the help of a tide table, it becomes easier to predict the trends of the marine life. For a shipping business that deals with fisheries, a low tide prediction with the help of a tide table will be able to pinpoint the location of a certain breed of fishes which gather in schools only during low tides. This will help the business concerned to catch more fishes and thus supplement their profit. Additionally, a tide table is a successful tool again because it helps construction companies to chart out the construction stages of water bridges and other coastal construction. All in all, for the entire business community, the presence of a tide table helps to solve their problems which would have never been solved otherwise. The working of a tide table is a simple process. There are reference stations which acts as reference points along the coast for the measurement of tides. With the National Ocean Service, the organization that collects up and publishes tidal data for a number of areas with the help of relative variant known as the mean lower low water. A table is compiled. Importance of monitoring tide. Commercial and recreational fishermen use their knowledge of the tides and tidal currents to help them improve their catches. Depending on the species and water depth in particular area, fish may concentrate during EBB or flood tidal currents. In some areas, strong tidal currents concentrate bait and smaller fish, attracting larger fish. In addition, knowledge of the tides also been interest to recreational beachgoer and surfer. Navigating ships through shallow water ports, intracoastal waterways, and estuaries requires knowledge of the time and the height of the tides, as well as the speed and direction of the tide currents. This way particularly critical to the sailing ships because they had to take advantage of the tides and currents to maneuver correctly. The depth and width of the channel in which they sail, and the increase of marine traffic leaves very little room for error. Real-time water level, water current, and water measurement system now are being used in many major ports to provide mariners and port operators with the latest condition.
Coastal engineering projects, including the construction of bridge docks, require engineers to monitor fluctuating tides level. Projects involving the construction, demolition, or movement of large structure must be scheduled far in advance if an area experiences wide fluctuation in water levels during its tidal cycle. Habitat restoration projects also require accurate knowledge of tide and current condition. Coastal zone engineering projects, including the construction of bridges docks, require engineers to monitor fluctuation tide levels. Projects involving the construction, demolition, or movement of large structure must be scheduled far in advance if an area experiences wide fluctuation in water levels during its tidal cycle. Habitat restoration projects also require accurate knowledge of tide and current condition. At which position will the moon be during a neap tide? The answer is 2. At which position will the moon be during spring tide? The answer is 1. The tidal range will be greater when the moon is the position 3 than when the moon is position 4 because position 3 is very near a spring tide position. That's all. Thank you.